Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content.
Before we begin, I'd like to thank Maths for Africa for allowing us to use their material. They really have some excellent resources, so have a look at their website and see what's available for you. Hi there everybody, I hope that you are well. Today we are going to be dealing with general solution, but in this case we are going to be dealing with more complex examples. So let's look at the first example. We see that sine theta is equal to cos theta. Now what we saw in the previous video was that sine theta is equal to a half, but what we have here are two ratios. And I want to show you what to do in this case. So when we have sine theta is equal to cos theta, what we need to do is try and get it to one ratio. And you've done identity, so you know that sine theta over cos theta is equal to tan theta. So if I divide by cos theta on the left hand side and the right hand side, that will give me tan theta. Is that not right? So tan theta will be equal to 1 because cos divided by cos is 1. What do we do now? What we do now is we do shift tan and 1 and to find our reference angle. And we find that our reference angle is equal to 45 degrees. If you look at the 1, you'll see that it's positive. Where's tan positive? Tan is positive in the first quadrant and in the third quadrant. And so those are going to be the quadrants that we use. Let's look at what we do in the next page. So look at quadrant 1. We have 45 plus K180, and in quadrant 3 we have 180 plus 45 plus K180. I want you to take special note of the K180. Why is it K180? Well, what is the period of a tan graph? The period of a tan graph is 180 degrees. What is the period of a sine and cos graph? It's 360 degrees. So when we are referring to a sine and cos graph, we always say K360, but when we refer to a tan graph, it is K180. Let's look at example 2. We have cos x is equal to cos of x plus 30. Now, when we have exactly the same ratio on both sides, the ratios will fall away. And what are we left with? We're left with x is equal to x plus 30. This becomes our reference angle. And if we look at x is equal to x plus 30, where is cos positive? Cos is positive in the first quadrant and the third quadrant. And so these are the quadrants that we will use. So for quadrant 1, we have x is equal to x plus 30 plus K360. And if you take the x over and subtract it, we are going to have 0 is equal to 30 plus K360. And that is going to not give us a solution. And in quadrant 4, we say x is equal to 360 minus our reference angle. And that's going to be 360 minus x minus 30 plus K360. So if we take that x over to the other side once we've multiplied out, it's going to be 2x is equal to 330 plus K360. Now don't forget, we need to divide by that 2 all the way through so that we have x is equal to 165 degrees plus K180. Do you see how that changes? It changed from 360 divided by 2 is 180 degrees. Please don't forget that this is general solution, and with general solution our sum ends we have K360 or K180. If you are looking for a video on specific solution, we do have a video on that. Have a look at our playlist and you'll find it there. Let's look at our third example. We have 2 cos squared theta plus 3 sine theta is equal to 0. But you know that cos squared theta is equal to 1 minus sine squared theta. That's from identities. And so what we are going to do is replace this cos squared theta that you see with 1 minus sine squared theta. And what does that give us? It gives us 2 minus 2 sine squared theta plus 3 sine theta is equal to 0. Alright, and what do we do with that information? Obviously, we want to write it in descending powers normally we write in descending powers of x. In this case, it looks like it could be a trinomial, so we are going to write it in descending powers here. And we have negative 2 sine squared theta plus 3 sine theta plus 2. When we multiply the expression by negative 1, we get 2 sine squared theta minus 3 sine theta minus 2. Because we want to factorize it, and we cannot factorize it, or we can factorize it with a negative in front, but it makes life a little bit complicated. So we multiply the entire expression by negative 1. And that gives us 2 sine squared theta minus 3 sine theta minus 2, which we factorize. And I always say to my students that when trigonometry, if it's too difficult to factorize as it is, change it to algebra. Change it to 2x squared minus 3x minus 2, and that you can factorize using the quadratic formula. So what we did was factorize that, and it factorizes into 2 sine x plus 1 sine x minus 2 is equal to 0. Now this gives me sine theta is equal to 2, or 2 sine theta is equal to negative 1. And we solve for that. Sine theta is equal to negative a half, and we have sine 2 giving us no solution. Do you know why that is? It's because the values must always lie between negative 1 and 1. This value must always lie between negative 1 and 1 for sine and cos. So if we look here, we've got negative a half, and that will give us a solution. So let's look at sine theta is equal to negative a half. Where is sine negative? In the third quadrant and the fourth quadrant. And what we're going to do is place that in the third and fourth quadrant. So we found our reference angle. We went shift sine a half, and we found our reference angle equal to 30 degrees. And so we are going to say 180 plus 30 for the third quadrant plus K360. That gives us 210 degrees plus K360. And then in the fourth quadrant, we have 360 minus 30 plus K360. And that gives me 330 degrees plus K360. Please look out for that factorization in general solution. It can become quite tricky. And if you'd like for me to record a separate video with regards to general solution and factorization, please type it in the comments, and I'll definitely try to assist you. Thanks for watching with us today, and please don't forget to share this video with your friends. We'll see you soon.